body cream and the body lotions are ready. It's advisable you apply them immediately after. Okay, Her Majesty Easy World Science Channel is an online school of science where you visit and learn all the things you need to know about science. We also teach skill acquisition there, just for free. Learn at the comfort of your home, at school, anywhere you are, you can learn at any time. You don't need to pay us any school fees. And remember, the only way you can access us is to visit our channel on YouTube and subscribe. Subscription doesn't cost anything. It means to follow me up so that you can get updates on my channel. When I upload, you'll be aware that I've uploaded. And YouTube will not force you to watch. There is nothing like it is expensive. What you gain in our channel is more than what you spend in watching it. So thank you and visit. If you have any students in the university, in the secondary school, a science student for that matter, this channel is the ideal for helping him out or her out in assignments and most things that give them difficult, preparing them for exams, even exams, even external exams, IGST, even Cambridge. Most of them will tackle it very well.
Okay, nice to see you are there. This is Her Majesty's World Science Channel. We are coming live. This is the stream 4 for chemistry. Chemistry stream 4 for this forthcoming JAMB. Remember how it goes. As usual, we have done stream 1, 2 to 3, where we tackled in each stream there are 10 questions, and today I'll see new 10 questions also. And remember that these questions are actually a guide. It will help you know your weaknesses, because as a student you might think you have studied harder than any other person, but these questions will try to pull your leg and expose some of your weaknesses so that you will score very high during the examinations. So it is a guide actually. So we will tackle new set of 10 questions starting from question 31 to question 40. And remember that when I finish up these 10 questions, it's now left for you to come up with your own questions. First, let's display the set of questions that we'll handle today. And don't forget to ask your question in the comment box. I'm here for you. Just engage me in a live chat. Ask me your questions in chemistry, wherever you're confused concerning this forthcoming examination. I know that you might be finding some topics difficult, but by the grace of God, I am here to solve them for you. So let us see the questions for today. Okay. So these are the questions. So try your ability, check if you can handle these questions. So try providing the answers there in the comment box. Okay, we now go to our solving board, our normal notes. I think I have made something for today's live stream. Okay, yeah. Okay, so we'll lift the questions as usual. We'll lift the first one here. The first question here, that's question 31, says, which of the following chlorides cannot be recovered from their solutions by heating to dryness? So the answer to this is actually option D is the correct answer. This is the correct answer. Option D, that's iron 3 chloride and zinc chloride. Remember, there are two methods of recovering soluble salts from their solutions, and these two methods of recovering soluble salts from their solution are evaporation to dryness and crystallization. If you don't use evaporation to dryness, you use crystallization in recovery. Then evaporation to dryness and crystallization. These are the two methods. Then the method number one is used to recover salts that are not decomposed by strong heating. Used to recover salts that are not decomposed by stronger heating. That is, salts that are stable to heat. And in this procedure, that is evaporation to dryness, you are just required to heat the solution until you sacrifice the whole solvent. That's the whole solvent will evaporate out and leaving behind the solid particles. Now, the problem with this type of this method of recovering is that substances or salts recovered by this method is not all that chemically pure. The purity is not to be compared with that one recovered by crystallization. Then, common salts recovered by evaporation to dryness includes all the chlorides except, so the question is just tempting you, all chlorides are recovered by evaporation to dryness except these two chlorides you are seeing there, iron 3 chloride and iron 2 chloride, even zinc 2 chloride. You don't recover them by evaporation to dryness because they usually have water of crystallization attached. So that is the answer. Then crystallization is used to recover salts that are destroyed by strong heating. You use this to recover salts destroyed by strong heating or decomposed. Salts that are decomposed by strong heating are recovered by crystallization. So we are done with this question, but before then, what are the examples of such salts? So most sulfates, most tetraoxosulfates are recovered by crystallization. Then some nitrates, few nitrates actually, but most sulfates like washing soda, a carbonate also is recovered by crystallization. And in crystallization, heating is still required, but you don't heat until the whole water goes off. No, you heat to concentrate in crystallization. Then you cool rapidly, and crystals will be formed from the solution. You can watch my video here on how to produce lead 2 nitrates. I produced lead nitrates and I recovered it by crystallization. Like I said in evaporation to dryness do not ensure high purity, but crystallization ensures high purity of the salt recovered. So there is high percentage purity for salts recovered by evaporation to high percentage purity seen in salts recovered by crystallization compared to that of evaporation to dryness. So we take a look at next question. We clean our notes, then shift this out, lift the second question. We go to question 32. Where can they be found? Okay, exactly. We are where we're supposed to be. So please, that the question is not clear, is now clearer. Watch the screen now. You can see them very, very well. I'm going to zoom them in. So, question 32 is an applied question, practically applied question, just checking if you know what it means. Okay, so I hope it's very clear. So they say, the question says, Majesty discovered that Odinkema left the reagent bottle containing concentrated H2SO4 uncovered in an open moist air outside the laboratory after practical for a week. Which of the following statements is true about the H2SO4 in the bottle? Option A says the pH decreases, the volume of the acid decreases, the pH increases. D says both the pH and the volume of the acid remains unchanged. Both the pH, you see clear, remains unchanged. That's not correct. The correct answer here is, but before then, this question is trying to check if you understand that conc H2SO4 is hygroscopic, meaning it absorbs moisture when exposed. So which means it absorbs moisture to get itself more diluted, and being more diluted means that the volume will increase. So exposing concentrated H2SO4 will increase the volume, and when the volume increases, the concentration will automatically decrease because water is absorbed. Why? Conc H2SO4 is hygroscopic in nature. So looking at the option, the pH decreases. No, the pH decreases means that it will become more acidic, which is not true. When you dilute it, actually the number of hydrogen ions compared to the volume present will decrease. And when the number of hydrogen ions decreases, it means that pH will increase. So lesser hydrogen ions means increase in pH. So option A is incorrect. Then B says the volume of the acid will decrease. Never, because the acid will absorb moisture and increase to its original volume. So the volume will not decrease, rather it will increase because it will absorb moisture, and that makes it a hygroscopic substance. Then C says the pH increases. Yes, of course, the pH will increase because it will become more dilute. Then both the pH and the volume of the acid remains unchanged. So the D is not correct. The acid is not going to remain unchanged. This means that concentrated H2SO4 is sensitive to the environment because it is what? A deliquescent. Then we go to the next question. That's question number 33, as you can see there. They say, which of the following compounds of nitrogen is used as a mild anesthetic? So you say, okay, thank you for being with me there, Frank. It's nice to know that you're always there. So God bless you. Share this particular live stream with your friends. Tell them the benefits, of course. Spread the light. And remember that your success is my priority. I will also take you in WAEC just immediately after this JAMB. You know that JAMB is only for Nigerians, but it's still within the same scheme. It's not even within, it's the same scheme of work they share with WAEC students because it is still O level. So thanks for being there. And some of you there that are still watching me live, I really appreciate. Come with your questions there in the live chat, but it will be better if you wait till I finish. So question 33 says, which of the following compounds of nitrogen is used as a mild anesthetic? Anesthetic means what? An anesthetic, that's what matters. These are actually painkillers. We call them the insensitized pain receptors, and they are used for surgery. That's why you can see someone cutting your flesh or your muscle with knife and you still remain relaxed without complaining. Is the work of anesthesia, and all anesthesias are anesthetic. That is the effect whereby you don't feel pain anymore. So the common ammonium compound actually is laughing gas. There is no further explanation there. Laughing gas. Some old scientists like Humphrey Davy, of course, was a bit addicted with laughing gas because of the fact that it gives you euphoria, it keeps you happy without hangover. So he was trying to say that it was better than alcohol. So please, laughing gas, otherwise known as dinitrogen-1 oxide, is a common anesthesia used in dental surgery those days. So there are other anesthesia apart from dinitrogen-1 oxide. Other anesthesia includes trichloromethane. You can see chloroform. So chloroform is also a common anesthesia. The formula is CHCl3. That's trichloromethane is also a common laboratory anesthesia. So we move to next question, question 34. The form of carbon with a metallic property is, carbon exists in different forms, in different allotropies, and which of them have this metallic property? Graphite is the correct answer. So graphite is the one with a metallic property. The answer is A, graphite. So graphite have the ability to conduct electricity, as we all know, and that's why it's used in Leclanche cell. That is some of the dry cell you use to power your remote, your common electronic device at home. So this battery is called Leclanche cell. The rod in the middle is graphite. It conducts electricity, and that's why it can serve as electrode in most electrolytic cell and also electrochemical cell. Diamond doesn't conduct electricity. You know that conduction of electricity is a property of metals, not that of non-metals. That's why it is not 100% correct to say that metals are elements that conduct electricity. You have seen it here. Graphite is carbon. Carbon is non-metal, and it is conducting what? Electricity. So we move to question number 35. We need to remove this. So we reduce this back to each side, clean the board. Okay. Okay, this is just the ones we answered now. This 38. I think we need 35 now. Okay, that's it. Got it. So question 35 says, razor blades are made from A, tampered steel, B, wrought iron, then C, pig iron, D, cast iron. Please try your ability, provide an answer to this, because I know this is a common question. Razor blade we use, it is actually the correct answer is A, tampered steel. Then what is tampered steel? Try your ability there. Tampered steel is just, you know that steel is an alloy of iron and carbon, but the temperature at which this is produced is heavily controlled. That's what we call tampering, just heating and cooling at a controlled temperature. So tampered glass is just the answer. That's what razor blade is made up of. The reason for the tampering is just to keep it more tensile and more heat resistant, just like you have your tampered glass for the one you use for center table. Of course, it gives it more strength. Then we move to the next question, and that is question number 36. Which of the following is not a greenhouse gas? Which of the following is not a greenhouse gas? You know that greenhouse gases are actually gases that have the ability to absorb heat from the surrounding. They absorb heat from the surrounding, which means they heat up the earth. Indirectly, they heat up the earth by increasing the temperature, and there is a very big risk. Is a risk to the environment, of course, because it might cause other side effects like maybe continuous rainfall and some other things. Then look at the options: sulfur 4 oxide, carbon 4 oxide, ozone, and methane. Please, the major greenhouse gas is actually carbon 4 oxide. Then methane is also a greenhouse gas. Then ozone is also a greenhouse gas. I can now see you know the answer. So the one I didn't call is option A. So option A means sulfur 4 oxide is not a greenhouse gas. So greenhouse gases are gases that absorb infrared radiations. The outstanding greenhouse gas, like I told you, is carbon 4 oxide, but other gases like ozone, methane, nitrogen oxide, and equally chlorofluorocarbons, which is not here, contributes in global warming. Remember, global warming is also called greenhouse effect somehow, because greenhouse effect absorbing heat. When this heat is absorbed, it warms our earth, and our earth here is globe, and we call it global warming. So this is also referred to as greenhouse effect, of course. Sulfur 4 oxide is not a greenhouse gas, please, but it causes acid rain. It dissolves in water to produce an acid rain because it's an acid anhydride. So the correct answer here is option A. Sulfur 4 oxide is not a greenhouse gas. Rather, it is an acid anhydride that when dissolved in water causes what? Acid rain. So we go to the next question. Okay, it's incomplete here, which means I have to lift another one, maybe from the video. They say tetraoxosulfate 6 is good dehydrating agent, but can also be dehydrated using. This is a very nice question. You know that tetraoxosulfate 6 is an acid. I want to discuss that in detail before bringing the complete options here. H2SO4 is a unique acid that have some specific properties that we need to know. H2SO4 can play 3 roles in a chemical reaction. It can serve as as an acid. So as an acid, it will react with bases to form salt and water, and that is neutralization. Then the same H2SO4 can also act as a dehydrating agent, Then the same H2SO4 can also act as an oxidizing agent. You might even add the third one. Maybe it can stand as a medium to protonate. It can serve as a source of proton. Like when you need an acidic medium, when you need more hydrogen ions for a particular reaction to proceed, the ideal here should be H2SO4. So when is H2SO4 acting as an acid? Normally, when it is dilute and cold, it acts as an acid. But when it is concentrated, it will make it act as a dehydrating agent. That is to remove water molecule that is chemically attached to it. Dehydration is a chemical reaction in a way that it affects the chemical nature of that compound. But drying do not affect the chemical nature. Dehydration is just to remove the water molecule that is chemically attached to a given compound. For example, in a hydrated salt like copper 2 pentahydrate, if you add conc H2SO4 to it, it will remove that water molecule attached to it. So H2SO4 can serve as an acid, as a dehydrating agent, but before it dehydrates, it's going to be concentrated. Even in the preparation of ethene from ethanol, for example, I want to show you where it is acting as a dehydrating agent. Good example is in the dehydration of ethanol, which is C2H5OH. You find out that if you remove water molecule from this, and what will remove it is conc H2SO4. So H2SO4 will remove H2SO4, please. We remove water here, and water is H2O. We have 6H here. Remember that carbon is constant, but when water molecule is removed here, it remains only H4 because we have 6H and 1 O. Removing 2 makes it 4, then removing the remaining O there makes it 3. So in this case, H2SO4 is acting as a dehydrating agent, not actually as an acid. Then, when is it acting as an oxidizing agent? The two conditions for H2SO4 to act as an oxidizing agent is that it must be 1, concentrated, and it needs to be hot. So hot concentrated sulfuric acid, in any reaction it engages, it is engaging as an oxidizing agent. So good example is this. If you react metals with dilute H2SO4, it is acting as an acid, and that is displacement reaction. But when you react H2SO4 with concentrated H2SO4 with metals, hydrogen gas will not be produced. Rather, it is an oxidation reaction that will proceed. So as an oxidizing agent, if you see H2SO4 plus zinc, if it gives you zinc tetraoxosulfate 6 plus H2, this makes it an acid. In this reaction, it is showing that this H2SO4 is acting as an acid. Then, but what if you have the other way around, H2SO4 plus zinc to give you zinc tetraoxosulfate 6 plus water plus SO2. In this case, this is an oxidizing agent. It's not acting as an acid, and this is no more displacement reaction. So if they ask you what is the gas liberated when concentrated H2SO4 reacts with zinc metal, even aluminum metal, all other metals above hydrogen in the activity series, it is called redox reaction. It is not displacement reaction. So if you want to prepare hydrogen with H2SO4, you need to dilute it. It should be dilute. But when it's concentrated, oxidation reaction will take place. Just watch it. The hydrogen liberated will be oxidized to water. So that's it for H2SO4. Then the question that I used, the question that took me to this point is, this question here, asking us that, let's get our board clean. This is the question, that conc H2SO4 is a dehydrating agent, of course. And remember, H2SO4 bonds. The corrosive nature of H2SO4 is because of its dehydrating ability. So it burns your skin when it comes in contact with your skin because it's removing water molecules from you. Then this question says it's a dehydrating agent, but there is another thing that can dehydrate it. And what is that thing? So we need to play the video for the questions to display fully. We are into question 37. Okay, you see it stopped at option C. Please, you see option D here. I hope you can see it very clear for those that are still there online. Option A says magnesium oxide, lead-2 oxide, then fused calcium chloride. None of them is the correct answer. Then let's see option D. Option D is phosphorus 5 oxide. So the correct answer is phosphorus 5 what? Oxide. So please, you can dehydrate H2SO4 using phosphorus 5 oxide, which means phosphorus 5 oxide will dehydrate it to give you SO3, sorry. So you can produce sulfur 6 oxide by dehydrating H2SO4 with phosphorus 5 oxide. So you have seen where a killer have seen a higher killer. So what will you learn from this? Between these two compounds, phosphorus 5 P2O5, but is a dimer, it occurs in this form actually. So this is the correct formula for phosphorus 5 oxide. It is more powerful dehydrating than conc H2SO4. You use this also to dehydrate HNO3 to give you NO2. If you use this, you dehydrate this to give you SO3. That's sulfur 6 oxide. So we go to question 38. Okay, question 38, you can see there. It says that in order to prevent dizziness and fainting during smelling of salt, which of the following salts should be used to smell other salts? So imagine a salt needed to smell other salts. So the easy thing there is that they are just asking you which of them is unstable. Which of them is unstable? Among these compounds here, option A says ammonium chloride, B says ammonium carbonate, then C says sodium chloride is very stable, you can't use it to smell it. Then D says sodium carbonate. Then what the statement I just have to drop here is that ammonium carbonate is this ammonium carbonate decomposes at room temperature. You can endeavor to watch my video here on how to make ammonia gas. Of course, I use this ammonium carbonate. It naturally liberates ammonia, so it's very obvious. So the answer should be ammonium carbonate. This is because it decomposes slightly even at room temperature to liberate ammonia. It is used as reagent in testing for calcium ions. Ammonium ethanoate is also used in the same similar reaction. So if you use that ammonium carbonate, you will know when you have started inhaling too much, so you will avoid it. That is why the odor is very, very obvious. So if you can place it and perceive the odor, it shows that the other gas can even access you. Then number 39 says, which of the following atoms have no bonding electron? But here it says has no bond electron. The atoms that have no bond electron, remember, they are asking you the atoms that do not react at all. So the atoms of the group 0 elements, that is group 8 elements, known as the noble gases or monoatomic gases. They don't have any bonding electrons. Out of the valency electrons, none is available for bonding. They are okay with themselves. They neither gain nor lose. So check from the options which of the following atoms have no bonding electrons. Sodium atoms, they have bonding electron. The last electron in the outermost shell, which is 1, is used for bonding. They can easily lose it to attain octet stability. Then chlorine atoms are very much available for bonding. Then helium atoms don't have any bonding electron because it's among the noble gases. Then hydrogen atoms, yes, have bonding electron. So please, from this, it shows that the answer is helium. Please, any other noble gas can serve. Remember, noble gases includes helium, neon, argon, krypton, xenon, and radon. Yeah, these are the noble gases. You can use the acronym He Never Acknowledged Knowing X mass rhyme. Watch my video here on the periodic table so that you can master all the elements in the periodic table and their groups also. Helium, neon, argon, krypton, xenon, radon. You can say he never acknowledged knowing X mass rhyme. So before we continue the last question for this particular live stream, let's take a little break.
Hi, my name is Catherine, and this is the Majesty's World Science channel. I'm a subscriber to this channel, and yeah, I've watched all his videos. It's like totally amazing. I watched his first DIY video on body lotion, and yeah, amazing. The product is like very good. This will like nourish your skin, and it will bring out the beauty in you. Remember to subscribe to Some Majesty's World Science channel on YouTube, and there you'll find a lot of amazing videos, and yeah, they are very educative.
So today we learn how to name disubstituted compounds of benzene. A disubstituted compound of benzene was one remains metal. So this is M-dichlorobenzene, while this is now P-dichlorobenzene because 1,4 represents. Let's see the next example. Okay, benzene. Then dimethylbenzenes are commonly called xylenes. But the CH3, CH3 are in 1,2 position, therefore this is called O-xylene. This one can now be called M-xylene, and this is called. This is the vertebral column. So we will take a look at the bones that makes up the skull, the tree canal here. So that's where your ear should be. Let's place the ear there. Okay, see? That's where the ear is supposed to be. It is the temporal. First, let's clean the board.
Hi guys.
My name is Shamika Arizi, and I am a second year medical science.
My name is Sushma Tripathi, and I'm a first year medical student.
We're here today to ask you to please subscribe to Sir Majesty H2SO4.
It has cool experiments and it makes science fun. So, subscribe.
Please.
Okay, welcome back. Remember, you are still live with Her Majesty is the World. Please, in this today's live stream, you have only one question left. Then I welcome your own questions if you have any. But if you don't have, we now call it a day for the live stream. You are still live with me, so it's nice to know that you are there. And remember to tune in same time. There will be live stream every Wednesday, Thursday, and Friday here by 2:30 p.m. That's GMT +1 Nigerian time. Endeavor to join. For some of you that don't have access to free Wi-Fi, you can use your daily subscriptions to watch me live. It is cheaper to do that. Then you can also book for your private classes. For your private online classes, they are cheaper and affordable, of course, but they are never free. Then, if you want me to handle any project for you in terms of laboratory equipment, I am here for you. I give the best service and the best quality, the chemicals you need. I give you the quality control because there are many adulterated things there. So thanks for being there. And let's now finish up with our 10 questions today. So the last but not the least question says, which of the following is not an ore? Okay, which of the following is an ore of tin? Which of the following is an ore of tin? Malachite is an ore of copper. Calamine is an ore of zinc. Cassiterite is an ore of tin. So you can see that the correct answer is C. C is an ore of tin. So tin is actually gotten from cassiterite, or what we call tin stone. Tin stone. So that's SNO2. That's tin 4 oxide is called tin stone or cassiterite. While lead 2 sulfide is called galena. That's option D. Take note, please. You get lead from that. Then calamine, like you know your calamine lotion for treating wounds, especially for those of you that have suffered chicken pox. So if you use it, if you have chicken pox, calamine lotion is used. And calamine lotion is actually zinc carbonate, though mixed with little zinc oxide. So calamine is a natural ore of what? Zinc. Then malachite is an ore of copper. I told you is a mixture of copper carbonate and copper hydroxide, which is an important ore of copper. So the color is a bit light greenish in color. So that brings it to an end for today's live stream. If you have your own question or questions, you bring it. As I wait for you, let's play other live streams, the stream 1, 2, and 3. You see the questions. Then your job is to go and watch the stream so that you can get the answers. I'll start from that of stream 1. Let's check if this is 1. Okay, this is 2. Okay, this is stream 1. See the questions. Go and watch where I answered it.
Make it move, make it groove. Make it move, make it groove. Make it move, make it groove.
So that is it for stream 1. Now see stream 2 in chemistry.
Came true. You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove. Make it move, make it groove.
Okay, that's it for stream 2. Let's see stream 3. That's it right there.
Came true. You don't even know how very special you are.
Okay, nice to know you're there. Please. I'm waiting for your questions. If you have any, you bring it alongside. If you don't have, we call it a day. But I really need to appreciate my studio engineer, Obachin. So he has been instrumental to the growth of this channel, Her Majesty Easy World. He was my student, now he's my studio engineer. He has been there for this channel, and I really appreciate him for his sacrifices. So thanks a lot. I'm waiting for your questions, please. If you have any, our time is remaining but just 3 minutes to go. That's the nice guy there. Very cool guy. So that's my studio engineer. A nice guy. So thank you so much, Chinon. So he's a software engineer. He has been doing well, and he has been instrumental to the success and the growth of this channel. I really appreciate, and my joy is that he was my product. I trained him. Now he is up to something. So please come with your questions. We are almost wrapping it up.
I love you. Thank you for watching. I love you. Thank you for watching.
Thank you. Bye. See you in the next live stream.